In question 10, we have a system of linear inequalities. And this is nice because we get the opportunity to practice graphing some inequalities twice. And we need to carefully shade the solution region. That's the region that satisfies both of these. For convenience, I think I can paste this. Oops. Maybe not. That's okay. Um, Okay, so the first inequality is y's are greater than negative 1/3 x plus 4. And it's pretty simple to graph that line, the boundary line. Notice because this is the symbol greater than, I'm going to be using a dash line. Remember, if you've got greater than or you've got less than as a symbol for your inequality, the boundary line that you sketch should be dashed, indicating that that boundary is not included. So we have a y-intercept of 4 and a slope pattern of negative 1/3. So on our graph, we would start with this point right here at 4. And then if I do that's interesting. Then if I do my negative 1/3, it would be down 1 and then over 1, 2, 3. Down 1 over 1, 2, 3. Down 1 over 1, 2, 3. And let me just graph that line. So I'm doing this as a dash line, indicating that the points on this line are not solutions, but it's just the boundary of the solution line, of the solution set. Now that symbol was, it was y's were greater than, so when I look at it, I'm going to be plotting y values that are above this curve. So I'm just thinking in my mind, I'm going to be sketching above this curve. Okay, our other boundary line was a solid line. You'll notice it says that y's are less than or equal to 3x plus 3. I guess I'll use a different color for this one. So I have a y-intercept at 3, and my slope is 3, so I'm going to go up 1, 2, 3 units and over 1, up 1, 2, 3 units over 1. I could also go down 3 units and back 1 as well. So those are some points on the line, and the actual line would be just through those. And again, this is solid. The inequality said that the y values would be those things below this. So I'm thinking below the blue line, below the blue line, below the blue line, below the blue line. So since I'm thinking below the blue line and above the red line, it turns out our solution set are all of the points in this region above the red line and below that blue line, or the extended blue line. Any point that I select in this region will satisfy both of the inequalities. Any point that I select outside of that region will not satisfy both of the inequalities.